All right, so here we are with, I guess this is chapter 6 now, so we're looking at 6.1. I guess solving quadratic equations now. Okay, now. Keep saying now. How now, brown cow? Anyway, so what we looked at so far is a quadratic function where it equals y, right? We often have f of x there as well. We graphed this thing and we were looking at the x-intercepts and the y-intercepts and trying to find the vertex and getting the shape, opens up and down, modeling a bunch of those situations, whether they be optimization problems or whether they be a parabolic dish or a projectile motion, right? And the graph was kind of instrumental in figuring out what was going on. So what we're looking at now are quadratic equations. And the specific difference here between a quadratic function and a quadratic equation is that an equation is simply where y is equal to 0, right? So if you can think about where y is equal to 0, what we are essentially looking at now when we're solving quadratic equations is the x-intercepts. That is essentially it. That's all we're looking for now. So this entire chapter right now will be about finding the x-intercepts of these quadratic functions or quadratic equations, okay? Now, don't forget that those are also called not just in x-intercepts, but solutions, right? They're also called roots. They're also called zeros, okay? So there's a bunch of different names for what we call solutions or x-intercepts, okay? Now, the first thing we're going to look at is factoring these things, okay? Because we've already looked at this in a variety of different ways, or lots of different times. We've looked for finding those x-intercepts, and the easiest thing is factoring. So in this case right here, if you could see that you could factor it, you'd end up with x minus 4 and then x plus 1. And then there's this thing called the zero product law. Remember that if a times b is equal to 0, you're telling me that a is equal to 0 and b is equal to 0. Okay? Well, that's the idea here. So if x minus 4 times x plus 1 is 0, that means you're telling me that hold on a sec here, x minus 4 is equal to 0, so x is equal to 4. And here, x plus 1 is equal to 0, so x is equal to negative 1. And those would be your two solutions. Okay? So this is the dealio with factoring, okay? Now, you're going to get a bunch of different styles of questions here, okay? Another one, for example, is here, all right? You don't have the whole trinomial, but hopefully you can see that you can still factor something out here, and you're going to be left with 3x minus 1, right? Now, if that's equal to 0, then you're looking at x equals 0. Well, look, there's an answer right away. The other one, 3x minus 1 equals 0, 3x equals 1, x equals 1/3. Boom, there's your other answer. Okay? So there's like an infinite number, there's like an infinite number, of different types of questions. So you just have to look at them all. Here's one, x squared plus 1. How the hell am I going to solve this? Well, let's go x squared is equal to, let's bring it over, negative 1. Well, hopefully you can see that you can't take the square root of this because it's a negative number. So what are you going to do here? Well, you're going to say that there's no solution. What the hell does no solution mean? How can there possibly be no solution? Well, what we're looking for are the x-intercepts. Well, what happens if it does this? Look, it opens up. It never crosses the x-axis. No solution. There you go. That's what it looks like when you get an algebraic example of no solution. You just can't solve it, okay? Well, look at this situation here. Wait a sec. I've got all these things already broken down into factors. So if this is all equal to 0, that means that x is equal to 0. It means that x minus 2 is equal to 0, or x is equal to 2. It means that 2x plus 3 is equal to 0, or 2x is equal to negative 3, x is equal to negative 3 halves. You end up having 3 solutions in that situation. Crazy, crazy. Well, what next? Gee, I don't know, Mr. Gregor. What else is there? Well, let's look at this one. In this case, it's not equal to 0. So what are you going to do? Well, you got to make it equal to 0. in order to make it equal to 0, you got to FOIL it out first. So x squared, and then you're going to have plus x minus 12x minus 12. Let's bring that 40 over. Plus 40 equals 0. And now x squared minus 11x, that's going to give me plus 28 equals 0. Now you ended up with a quadratic equal to 0. Solve it. Boom, 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 boom. X, 28 times 1, 14 times 2, 7 times 4. That's about all I can find. Boom. Minus 7 minus 4 all equals 0. So if x minus 7 is equal to 0, x is equal to 7. If x minus 4 is equal to 0, x is equal to 4. Boom. There's your two answers. Boy, it's just the same thing over and over and over. Let's see if we can sort something else out here. Another one, here we go. Oh, these are nasty. Okay, so what we have to do with this is find a common denominator. So that's x, x minus 2, and 8. So if you're going to multiply everything by that, let's write it out here. 1 over x plus 3 over x minus 2 equals 5 over 8. So boom, multiply this one out. The x is canceled, so you can have x minus 2 times 8 plus 3. The x minus 2, so it's going to be x and an 8 there. And on this side, the 8, so you got an x and an x minus 2. So we're getting rid of our denominators here. What we have to do now is just multiply it all out. So we get 8x minus 16. This gives me 24x. On this side, sorry, that's an x minus 2. So we'll have 5x squared minus 10x looks like. Let's make 0 on this side. We've already got a 5x squared here. 8x, 24x, that gives me 32x on this side, minus 32x on this side. That's minus 42x total, and then a plus 16. So this looks like a kind of a gnarly quadratic to solve, but let's give it a shot. I don't have any other choice but 5x and x. I'm looking at 16 times 1, 8 times 2, 4 times 4, 8 and 2. Look at that, 8 and 2, minus and a minus. That gives me minus 42x and plus 16. So now 5x minus 2 equals 0. 5x equals 2. X equals 2 fifths. X minus 8 equals 0. X equals to positive 8. There's your two answers. Longer question, still doable. Okay, I think we got one more here maybe. A couple more looks like. These are quick and easy though. A couple different ways to do this. If you could see that it is a difference of squares, you could see that you'd have x is equal to 4 and negative 4 right away. You could also solve it just by what we call the square root thing here. Move it over, becomes 16. So the square root of that, the square root of that, you get x is equal to plus or minus 4. Same answer in a different way, okay? Same answer in a different way. Let's look at one last one here, I think it is. No, two more, sorry. Here's another one. Well, you don't have the middle term here, so we can kind of work a little bit of algebraic magic here. You can simplify it to get the x, and then x alone, and square root it. So you got x is equal to plus or minus the square root of 8/3. And we can talk about how we simplify that too. That's the square root of 8 over the square root of 3. If you remember how to simplify radicals, it's going to be like that. And then you might want to get rid of the bottom. So you go like that. It ends up giving you 2 root 6 over 3. And don't forget that it's a plus or minus. So that's a little bit trickier for sure. The final step, but as long as you understand the math here, I believe we're on the last one here. Let's have a look at this, folks. If I wanted to get rid of that square, what I can do right away is actually square root it. So I square root that side, and I end up with x minus 1 is equal to plus or minus 3. At this stage, what you need to do is solve two different ones, right? X minus 1 is equal to 3. X minus 1 is equal to negative 3. Here you have x is 4. Here you have x is, negative 2. And those are your answers. Now remember, all these solutions that you're getting, All these x values, they are all the x-intercepts. So they are where it crosses the or the x-axis where your y is 0. Okay? There we go. See ya.